Hello and welcome back to Introduction to Physics. We're going to be doing a lab today on energy and then using energy in order to predict how long it will take an object to stop moving on the floor. So if you will go to Canvas, Modules, Labs, Unit 1 Labs, and then down at the bottom of the Microsoft Excel worksheet, click on the tab that says 1.6b, Energy and Motion. So that is the lab that we're going to be doing today. Okay, got it? So, you first need to read the concept introduction. So please do that now. Go ahead and pause me. Okay, now you should be able to answer the pre-lab questions. So number one, what is the purpose of the lab? So go down into the lab, find the purpose, and then copy and paste it. Okay, what are the safety instructions? Well, this one's a pretty safe lab, so there aren't any safety instructions on this one. What is gravitational potential energy? So if you've read the concept introduction, you know what that is. I would like for you to put the formula for gravitational potential energy. Okay, question number 4, what is kinetic energy? So write down the formula for it. Again, you can cut and paste on this. Okay, what is work? So find the formula for work and cut and paste that one. Now, question number 6, what does conservation of energy mean? So when energy is conserved, what's going to happen? Question number 7 is to write down Newton's second law of motion. Question number 8 is to write down the how fast equation. So remember that there were 2 equations that you studied back in unit number 1, and they were the how fast and the how far equations. So you might need to go back in your notes and find the equation for the how fast and then put it in there. Okay, now we're going to go down to the materials. So the materials that you're going to need for this experiment are going to be a ramp, and if you don't have a ramp, you should have a Monopoly game or something like that where it has a board, and then take the board and then put it on top of some books or something, and now you got your ramp. So it should, I hope it's not going to be too difficult for you to find something to roll the ball down. Okay, you're also going to need a ball, and it doesn't make really any difference the size ball that you use. As a matter of fact, what you could use, and I do recommend this, so instead of using a ball, because later in the lab you're going to have to measure the mass of that ball, and the problem is that you probably don't know the mass of your ball. Instead, why don't you get a can of mushrooms or a can of tomato paste, okay? Because on the can it will tell you what its mass is. So it will give you the mass in grams. Now that doesn't include the mass of the can, but we can't help that. So we should be able to get a ballpark answer that's correct. So I would get a can from the store, and it doesn't make any difference the size of the can. I would get a small can, and then write down what its mass is. Okay, then you're also going to need a ruler, and then also you can get away with just using a ruler, but I would use a tape measure. So if you happen to have a tape measure in meters, I know that that's kind of difficult. If you have to, you can do it in inches, but then you're going to have to convert it to meters, which is kind of a pain. But you can do that on Google very easily. So if you type on Google 12 inches and then put an M next to it and then hit enter, then it's going to tell you how many meters is equal to 12 inches. So you could do these conversion factors on the computer if you have to. So a tape measure in inches will work on this experiment. Okay, then you're also going to, well, that's it. So you don't need the mass balance, because I said if you use a soup can or something, it tells you what the mass of the can is on the side of it. So you won't need the mass balance. Okay, now let's go down. You should have read the concept introduction, so I'm going to skip all of that, and let's go down to the procedure. So you're going to take your ramp, you're going to put it on the ground, and then prop it up with some books. Now I would not, don't do that for heaven's sakes, because when that can hits the bottom of the ramp, it's going to bounce. So what I've found is smaller is better. So maybe if you raise your ramp by about 3 inches to 6 inches, that's going to be more than enough to do the experiment. So you don't want to have too steep of a ramp for this. Okay, then you're going to take your can and you're going to place it at a certain height on the ramp. Now that is going to be a vertical height. So let's say that you put your ramp like this, okay? You're going to measure the vertical distance to the ramp, and that's where you're going to put the can. And then you're going to let the can go. It's going to roll down the ramp, and then when it gets to the bottom of the ramp, you are going to measure two things. How far did the can roll? And then also how long did it roll? So you're going to need a stopwatch for this. And you should be able to use your cell phone as a stopwatch. So when the can gets to the bottom of the ramp, click your stopwatch. When the can stops rolling, click your stopwatch. So we need to know the amount of time that the can rolled on the ground. And we also need to know the distance the can rolled on the ground. Okay, now what you're going to do is don't change the angle of your ramp, but now put the can at a different height. So that means you're going to have to move it further up the ramp in order to be able to do this. So now you're going to have another height, and you will release the can from that height and then repeat the whole experiment. So that you should have 5 different heights that you're releasing the ball from, and then you will and that I'd like for you to do it 3 times for each of those heights, and then average it, because that'll give you better results. So you're going to have 5 different heights, and you're going to have 5 different average times and 5 different distances that the can rolled on the ground. And you're going to take all of this information and you're going to put it into data table 1.61. Okay? Alright, so I'm going to stop the video here, and then we're going to talk about how to analyze this data.